Going to all. Today we will discuss the topic in COA, is restoring division. So before going that, you have to understand the flow chart. Initially, the flow chart start with star, and we are going to initialize A, that is accumulated with 0 only, and M always consider divisor, and Q as considered as a dividend here, and count is N, that is number of bits. Most probably we are doing with 4 bits. Suppose the N value is 4, that is 4 bits binary number, we can consider as a count is 4. And compulsory, the rule says here we have to perform the shift to left operation, then we can perform the A minus M, that is accumulator minus M, that is uh, division operation. Then we have to check the value of accumulator is less than 0. If at all less than 0, what we can do? We can go for check the Q0 value, and that is become that Q0 value is 0. That we have to perform again A plus M, that is addition operation. Then you can go for reduce the count and go for the next count. If count becomes 0, you can stop the operation. So again we can go for shift left and again perform the A minus M, that is subtraction operation. Then check the bit value. Suppose if bit value is not less than 0, you can perform, that means the Q0 value become 1, and we can reduce the count and go for the beginning. We'll get the solution. Yeah, let's consider the sum. We are going to consider example for restore division. The dividend given is 1011 and divisor given is 0011. Here that is the divisor is the B value, where I'm missing the pen. So here we have to consider the 4 bits of division, and we have to follow here the n plus 1 A, the rule n plus 1 is equal to A bit, some rule is there. So we have to add additionally 0, so it becomes 0011 here. Then this is the divisor value B value. Now we have to find the 2's complement, because we are going to perform the what operation? We have to perform the subtraction operation, and we need support of this one. So the rule says, so we are writing the B's complement, that is 1 1 1 and 0 1, because 2's complement is what? We can write the number, add with 1, it becomes 2's complement. This is the B value. And now we can start the operation. Initially we are assigning accumulator value is 0 0 0 0, 5 digits, and the Q quotient value is what? 101, where we are taking from the sum only. So this is the initial one. Now we can perform the operations based on the flow chart. So first initially what is there? 0 0 0 is there and is there, and first we have to perform the shift left operation. What is the one? Shift left operation. So shift left operation, we have to ignore the first bit. So you can write the code here. Okay, sorry, numbers here. 0 become here, and next 0 become here, next 0 become here, and next 0 become here, and 1 become here, and again 0 become here, and 1 become here, and 0 become here. This is the shift left operation as per the flow chart. Now we can check the, so now we can perform the which operation? We can perform the A is equal to A minus B, that is what? Subtraction operation. So A is equal to A minus B, that is what? A is equal to A plus B is to complement. The meaning is what? A plus B is to complement, because we can perform the subtraction easily here. So B is 2's complement is what? 11100, where we already find out, where we got and note down here 11101. So what you write? We can do the shift subtraction, that means add the B's 2's complement value, that is what? 11100. If you add, what will happen? 1 plus 1 0. Okay, again 0 plus 1 plus 1 0, carry 1, so it become 1 plus 1, 1 plus 1 0, again 1 plus 0 1, again carry 1 is there, and 1 plus 0 1, again 0 plus 1 1, and 0 plus 1 1, and here also 0 plus 1 1. So what will answer, what in the initially will get the answer of 0 1 1 1 1 1. Now the rule says here this is the negative value. What is on? The A's value is negative, so we had set the Q0 value. Listen carefully. So if you want to set the Q0 value, instead it is empty, we can set as 0. If the accumulative is 1, we can set 0 and go for register procedure. Suppose the accumulative is 0, we can write the Q0 bit as a 1 and stop the operation and go for next step. So in this entire restore operation, we are performing the shift left operation followed by the subtraction operation, and we check the a value. If it a value less than 0 what and greater than, if it less than 0, we can go for the set Q0 value is 0 and continue and reduce the number of counts and repeat the operation. Go for the next step. So this is the insert step. So, yeah. So we can perform the next step. So here, the pen again. So here subtraction over. We are setting the Q0, set Q0 as a 0. Then we can perform the, as per the flowchart, we can perform the addition operation. That is what? So addition operation what? That is A is equal to A plus B value, not okay, A plus A is equal to A plus B value. So we can write the value of 0 0 0 1 that we are writing here. Yeah. So we are taking this value and going to substitute here, add it here. So 0 0 0 1 1. So now answer is what? 0 plus 1 1 and 1 plus 1 0. Again carry is there, 1 plus 1 0. Again 1 plus 1 0. Again 1 plus 1 0, and at last we have carry 1. So in this carry we have to ignore because we are performing the 2's complement and the rule says here. So any carry come, you have to ignore by default. Now what is the answer? It's the 1 and the same, and we're getting the 1 where we are going to again perform the shift left operation. So this is the 1 and the same number we are getting here because 0 1 0 coming here, and already told you if at all negative, that is yeah, accumulative value 1, we can cube set the cube 0 as a 0 here. Now we can perform the shift left operation. So we are ignoring the first bit. So yeah, so 0, yeah, so the 0 come here and again 0 come here, shift left, no, again 0 come here, sorry, we are ignoring the first bit. So use the pen again. So here you are performing the shift left operation. So 0 come here, this 0 come here, and this 0 come here, and 1 come here, and this 0 again come here, and this 1 move here, and this 0 move here, this 0 also move here. Now we're done the shift to left operation. As per flowchart, we are going to perform the subtract operation. So if you want to subtract operation, we have to add the b's 2's complement value. That is what? 1 0 1. So 1 change the color. So 1 0 1. So again you can add. So 0 plus 1 is what? 1. And again 1 plus 1 1. So 1 plus 0 1. Again 0 plus 1 1. And 1 plus 0 plus 1 1. And 0 plus 1 1. So again telling, if at all negative value come, you can go for restore value. Okay. If at all the accumulator 1 become, we can set the Q0 as value is 0. The rule says here. Now what you can do? You can perform restore the value. So if you want to restore the value, what you will take, we have to add the b value. B value is what? 0 0 0 1 1. So we can perform here. That is 0 0 1. If you add, what will get the answer? 1 plus 1 0. Again 1 plus 1. Sorry, 1 plus 1 0. Again 1 carry is there. So it become 1. Again 1 carry is there. So it will, yeah, 1 is there. 1 plus 1 again 0. Again carry is there. 1 plus 1 0. Again 1 plus 1 0. Again 1 is there. So again we are ignoring. The rule says here, 1 come, you can ignore, and the answer what you get here, the second step, 0 0 0 1 0 and 1 0 0. This will come down here. We go to the next step now. So we are completed the first cycle and the second cycle also. Clear it first. Right. So we continue the step here. So this step is over. So here, what we have to again we can go perform the shift left operation. So if do the shift left operation, you have to ignore the first bit here. Do the first bit, so you can move these bits here. 0, this 0 come here, and 1 come here, and 0 again come here, and 1 come here, and 0 again come here. This 0 come here, and this 0 come here. Now, what do you do? We have to go for subtract operation. So if you want to do the subtract operation, we can add the b's 2's common value. That is already given the sum 11101. So if you add, what you will get answer here? 1 plus 1 becomes 0 and carry 1. So 0 plus 1 1 and again 1 carry will come. Sorry, this is over. So 1 plus 1 0. Leave it. 1 is there. 1 plus 1 plus 1 0. Okay. Then carry 1 is there. So 0 plus 1 here. And again 1 plus 1 0. Carry 1 is there. Again carry plus that 1 plus 1 becomes 0. Again 1 is there. 1 plus 1 becomes 0. Again we'll get the carry. We can ignore the carry. Ignore the 1. We can ignore the 1 because we are following the 2's complement and the rule says here. Now what will get the answer in the third step here? That is 000 1 0. That is the accumulated value. And this become 000 1. That is the 1. What you are saying for quotient value. And remember you. So again we are going to set the Q0 value. And moreover, if at all accumulated value is 0, we can here the accumulated value is 0. So we have set the Q0 value is a 1. And no need to restore here. This is the third cycle. So we can perform the shift to left operation and we can perform the subtraction operation and restore the value. And if it are when go for the restore value, we have to check the accumulated value. If it are accumulated value 1 negative, we can set as a Q0 value is 0. If it are accumulated 0, we can write Q0 value is a 1. And here the n become first initially 4 now, n become 3. Then next step n become 2, n become 1, not 0. So you can perform one more step and get the solution and stop the process. Let's go for the solution. That's fine. Yeah. So we're going for the solution here. So I'm writing the third step and go for the final result here. Right? Some problems. Right? So what I tell the third one. So again we are going for the shift to left operation. So we are ignore the first bit. So 0 come here. Sorry. Yeah. So we're performing the last step, that is the now already n become 1, n value become 1. Once come 0, you can stop. So here the 0 come here, again the 0 come here, 1 come here, and 0 move here, and again 0 come here, this 0 come here, and again 0 come here, and 1 become here. Again we set the Q0 value. Sorry, yeah, again it's empty here, and we can go for the subtract operation. So if you want to subtract, we can add the these two's complement value, that is 101. So we can perform the addition operation. 0 plus 1 become 1, and 0 plus 0 again 0, and 1 plus 1 0. Again carry is there, so 1 plus 1 0. Again 1 plus carry is there, 1 plus 1 0, and carry is 1. So we are ignore the 1 carry. And here the accumulative value is 0. Now what we will do, you can set the q0 value, it become 1. I already told you, if at all negative value come, you can set q0 as a 0. Otherwise, if at all accumulative value is 0, you can write a 1 here. This is a rule says by the redistribution concept. So at last we are writing the answer, that is 0 0 0 0 1 and followed by 0 0 1 and 1. So this is the remainder and this is a quotient. So we are successfully solved the given problem. That means first cycle, second cycle, third cycle, and fourth cycle. We are doing the four steps of operation because the n value is 4-bit scale. So n is equal to 4. 4 times we perform the operation. At last we are highlighting the what is remainder and what is quotient. This is the final result. This is about how to resolve the restore division concept. Thank you.